All right, so again, from the other day, you would see a problem like this. So, Mary believes that boys' games have more fouls than the girls. I don't know. I don't think that's true, but whatever. Okay, cool. So what does she do? Well, she samples 50 of each. Boys average 20 fouls a game. Standard deviation 5.2. I said n equals 50. I already said that. The girls, 17.3. Cool. And so to do this, of course, H naught, this is what I heard. I heard her say that the boys bigger than the girls. That's what I heard. Opposite of that, of course, is they're equal. You with me? That's the opposite. All right, well, that's cool. So the upper tail test. Now again, under H naught, mu boys minus mu girls equals 0. Do you buy that? That's what we believe. We're going to do everything based on that. And so as a result, this z-score that I showed you the other day, under H naught, you see this thing is equal to 0, yes? And that 99% of the time, that will be a true statement. And then, of course, it's Sx squared over n plus Sx squared. This is 2 and 2. They're different, in other words. You can't add them. Da-da. All right, dog, let's do this then. So 20 minus 17.3 over the squirt of 3.2 squared over 50. My baby thinks oh, you idiot. $2.17. Hey, what are we going to do? We're going to reject H naught. We know that, right? Reject H naught. So what does that mean? Well, it means this is true, which means the boys have more fouls. And of course, what does that mean? It means Mary's right. And you could say it several different ways. Now, of course, I will still find a p-value because, okay, I'm a good teacher. Equals norm dot upper tail line minus norm dot s dot dis 2.17. 0.015. Why do I have two of these going on? I don't care. There it is. Yay, and the crowd goes wild. What do you think? Not terrible, huh? Not terrible at all. Let's do another, kids. Okay. But this time, Scott. Oh, yeah, Scott. Feels. Good for you, Scotty. That. He sees more cats per day than dogs. Okay, I guess, whatever. So he samples 15 days. Sample's 15 days. Sure, I guess. This is kind of a weird one, but I'm going to roll that. I don't really care. And so the average for cats, X bar is 37.3. SX is 7.2. Dogs, X bar equals what are you doing, boys and girls? You moron. Try dogs and cats. I heard, listen, this is what I heard. I heard dogs is less than cats. But that's not what she said, Mr. Groom. Okay, crackhead. If I'm taller than you, you're shorter than me. It's the same thing. So recall that under the null hypothesis, if you do dogs minus cats, and there's no difference because they're equal. You see this? Well, you get, there's literally no difference, 0. So once again, I chose to do dogs minus cats. Let's say I get a z-score here in a second of 1.7. Jilly did it the other way around. I'm going to get negative 1.7. Jilly's going to get positive 1.7 if she minuses it the other direction. You with me? Not a big deal. Now, there is one issue here. Oh, you're right, Groom. You wrote it backwards down here at the bottom. Well, it's addition, and addition is commutative, so it doesn't matter. But there is one problem. We don't have a big enough sample size, so we're going to use a t. But Groom, it didn't really change anything. As far as this piece here goes, you're right, it didn't. As far as the probability, of course, it will change a little bit on the probability. We'll do that in a moment. Negative 0.339. Well, I'm going to tell you right now, we're going to fail to reject. That's not far enough out. I can tell you that already. But I will look up a p-value. And again, I got negative. Jilly got positive. Failed to reject H naught. She would have done 1 minus in a second, but it's the same principle. Scott's on crack. Scott is wrong. He's wrong. He does not see significantly more cats than dogs. Or something along those lines. Are you with me? Nice. Now, in the old doohoo over here equals T, yes, 0.339. Now, the degrees of freedom is the smaller of the two ends, which they were the same in this case, but the smaller of the two ends minus 1. So if you had one that was 16 and one that was 14, it would be 13 degrees of freedom, so 0.63. Which means there's about a 63% chance that I would have seen something like this if there's no difference. Which means, hey, there's no difference, brah. Okay. That's what's happening. That's 2 sample tests for means for either Z or T. There's really no difference between the two, as you can see. Okay, it's almost fun. Well, let's don't be too excited. It's almost fun. All right, I'm gonna pause 1 moment, please. Pause. Hold, please. So the other thing I want to chat about is, well, can I make a confidence interval? So again, I don't know what the true difference is between these guys. No idea. But wait, Groom, last chapter we did the same thing, and we made a confidence interval for it. It was X bar plus or minus Z, sigma over the square root of n, or Sx over square root of n. That was our confidence interval. X bar plus and X bar minus, right? Well, I feel like we can do the same thing here. Well, actually, I write it like this. Can we do the same thing for 2? Absolutely. Mu1 minus mu2, dot, 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 dot. Instead of just x bar, it's x bar 1 minus x bar 2. And x bar 1 minus x bar 2. Yeah? Piece of cake. So again, this is your margin of error, just like before. And it's easy. Now, why would I do this? Well, here's what I say is under the null hypothesis, again, I told you this before, I'm going to tell you it again, we are under the assumption most of the time that they're equal to each other. Or in other words, mu1 minus mu2 is equal to 0. That's our assumption, correct? So let's say I made a confidence interval. And let's say that when I'm done, I have this. What does that say to me? Well, what number lives in here? 0 is in this interval from negative 3 to 5. So fail to reject. You with me? Every time. Let's say you do it again. Uh-oh, guess what's not in there? Well, 0's not in. 0 not in here. Therefore, what does that mean? Oh no, we're going to reject H naught. It's that easy. I know what you're thinking. Could this be negative 13 and negative 10? True dat, homie. Still not in there. Still reject H naught. Okay? We will do this. That's typically why we make confidence intervals with two populations. Okay? Boys, girls, loggers versus dentists. I don't know. Whatever. One moment, please. All right. So we want to know the... Molly, whoever she is, that's not our Molly, a different Molly. Molly wants to know something about the average difference in GPA basketball versus football. So what does she do? Well, obviously she goes and samples some basketball players. She samples 70 basketball players because I don't know. I think they're cute, Mr. Groom. 2.1. And standard deviation of 0.9. Football, she samples 60 of us football types. 3.0. That's not right. It is, bro. Basketball players are the dumbest of the dumb amongst us. Boys, that is. The girls' ones are typically smarter. Some of the boys' basketball players. We football players. I'm just saying. Okay, that's actually, Mr. Groom played basketball in high school, too. It's fine. So, does it matter which way I minus them? No, but it does matter which number you use. So, 2.1 minus 3.0. Is it going to matter that it's negative? No. Plus or minus. Z, so if I'm doing a 95% confidence interval, it's still 1.96. Let's go find that confidence or that margin of error first. I get 0.369. So negative not 0.9 minus 0.369 is negative 1.26 or whatever. And on the top end, mu basketball minus mu football. We're going to plus them. And we get negative 0.531. So if that's all she wanted to know, somewhere between a half and 1.25 points of difference is what we would say we are 95% confident that that's in there. But why would she really do that? Well, what she'd really do is this. Molly believes there's no difference, is what she's really saying. Maybe this is what she's actually believing in her heart. So she finally opened up to us and let us inside what she was really thinking. She believes there's no difference. In the GPAs, basketball versus football. Wait, did she change what she said a minute ago? Well, kind of. Two ways to approach this. Either she could have been going about to do a test on it, or she just didn't know, she wanted to have an idea. Okay, whatever. So let's say that she did this. Well, let's say she wants an alpha 0.05. Okay, we'll check it out. So in this case, wait, we already did it up here, Grim. We did a 95% confidence interval is equivalent a two-tail alpha 0.05 is equivalent to 95% confidence interval. It's important it's only on a two-tailed test. So Molly can just look up here and go, oh, dude, 0 is not there. We're going to reject H naught. Now, she can do that just by looking at it, right? Because 0 doesn't live in there. Or she can actually make a z-score, and she can actually tell me a p-value. Now, if all she wants is to reject, fail to reject, reject, because it's not in there. And so there's your data points, 2.1, so it's negative 0.9 on top. On the bottom is our margin. It's not our margin of error. It's this thing here, right? Oh, excuse me. And we're making a z-score, correct? You with me? And it's like, well, what if our z-score is bigger than 1.96 or smaller than negative 1.96? We're going to reject. I got news for you. It's going to be smaller. How do you know, Grim? Because we already rejected it the other direction. Would I do both of these? Now, of course, that'd be like boiling your egg and then turn around and poaching it, or like frying it first and then boiling it. That's weird. Are you with me? That's just odd. So pick one. Can I have the enter, please? Oh, look at that. Negative 4.77. What are you going to do? Again, reject H naught. So either you can do a two-tailed alpha 0.05 test, which I just did, or you could do a confidence interval. If all you want to know is there a difference? Hey, the confidence interval is pretty easy. But Groom, I don't know what the score is. You're right, you don't know the score. To do the score, I would need to use the norm.s.dist if I wanted the actual p-value. So negative 4. I'll tell you what it is. It's not very big. Oh, Lord. 0.60. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6 zeros, and then 9. Yay. Reject. All right, that's tiny. I want you working on those, okay? So, yeah. Good luck.